Bright Tuty. Every student matters.
Hello students, in this lecture we will be discussing some important questions related to the first topic of this chapter, that was force, a push or a pull, right? So the first question is, what is force? In the first lecture we studied that force in science, a push or a pull, as we just discussed before this in last topic of the chapter, a push or a pull on an object is called a force, right? And if we give examples, we can say picking a ball, kicking a ball. All of these are basically forces acting on some body, due to which another body came into a different state of motion, right? What happens to a moving ball after some time? What are the possibilities that may happen to a ball which has been moving? Firstly, it may slow down, right? It may slow down after some time. Secondly, it may be stopped, right? It may get stopped after some time. It may stop on its own, right? Thirdly, it may change its direction, right? And fourthly, it may slow down and change its direction, right? So these are the possibilities that are supposed to happen with the ball, with the moving ball, right? It may slow down after some time. It may stop on its own, right? A football, when you're playing, when you kick it, it may stop after some time, right? And it may change its direction. It is not always possible for an object to continue in the same direction. It may change the direction as well. It may slow down and change its direction. Basically, both can happen simultaneously, right? Now, what kind of force do magnets show? Basically, magnets show push and pull both when there are like poles near each other, right? When two magnets are present and both the north poles are close to each other, they will push each other away. They will repel each other. So this kind of force will be push, right? This is repulsion. And pull, there are two magnets, right? Here, so what is happening basically? Here, unlike poles are close to each other and unlike poles attract. So here you will be able to witness a kind of a pull force basically. So magnets show both kinds of forces, push and pull, right? Can a ball move without a push or a pull? For example, a ball is at a field, has been kept on the ground. Can it move by itself? No. Because no other body is interacting with that ball, the ball will not move by itself, right? How many objects are required for a force to come into play? There must be two objects interacting for a force to come into action, right? And if you give an example, you can give the example of pushing a car. You cannot push a car without contact, right? You cannot push a car without contact. So their interaction is important for the car to be moved. If in case your motive is to move the car, you must push it and there must be an interaction between your hands and the car so as to move the car, right? In the following picture, what kind of forces are taking part? Basically, students, this is a man and this is a bull. This man is trying to pull this bull towards himself, and this bull is trying to pull the man. Basically, bull is stopping himself from the force. So the force of bull is acting in the opposite direction. He wants to stay at this place, so he is not pulling anything. He is just making himself stop from moving, right? So here two kinds of forces are acting. First one by the man, which is a pulling force, and second one by the bull, which is again a pulling force. So these are the forces that have been taking place in this picture. What happens to forces which are acting in the same direction? What happens to them? They add up to each other. Whenever forces are acting in the same direction, they are added. For example, you were pushing this box, right? You were pushing this box in this direction. You applied a force of 10 units. And your friend also came and helped you by applying 5 units of force, right? So the net force acting will be equal to your force F1 plus your friend's force F2, that is equal to 10 plus 5 equal to 15 units, right? So the forces acting in the same direction are added to each other, right? Now if the two forces act in opposite directions on an object, the net force acting on it is the difference between the two forces, as we discussed in this. Basically, if the two forces are act in the opposite direction on an object, the net force acting on it is the difference between the two forces, right? Explain the forces acting in the following picture. As we have discussed in the lecture as well, this is the picture A, in which boy 1 is applying the force in left direction, right? And basically in this direction. The boy 2 is also applying in the same direction, right? So their forces F1 and F2, net force will be equal to F1 plus F2 because they are acting in the same direction. Say Fn, right? Fn is the net force. Now in the case 2, boy 1 is applying the force in this direction and boy 2 is applying the force in opposite direction. They are not working together. So the net force will be equal to F1 minus F2, which is equal to Fn, right? This was Fn1, this is Fn2. So in the second case, what happens is, because the forces are acting in opposite direction on the object, the net force will be equal to the difference of the two forces, right? And in the first case, the forces are acting in the same direction on an object, so they will be added to obtain the net force, right? Simple. When the forces are acting in the same direction, they are added. When they are acting in the opposite directions, the net force is the difference between the two forces, right? If the force is applied in the direction opposite to the direction of motion, then it results in the decrease of speed of the moving object, and ultimately it changes the state of motion of the object. Right? If a force is applied in the direction opposite, for example, the body was moving in this direction, and I apply force in the opposite direction, then it results in the decrease in speed of the moving object, and it changes the state of motion of this object as well. Right? Next question. What are the effects of force on speed? If it is in the same direction, it increases speed. Right? If you are applying the force in same direction, it will increase the speed of the object. If it is applied in the opposite direction, it will decrease the speed. Right? This is the effect of force on the speed of an object. When it is applied in the same direction, it increases the speed of the object. If it is applied in the opposite direction, it will decrease the speed. Right? Now, what do you understand by the change of state of motion? Whenever a force is applied on a moving object, it may increase its speed, it may decrease its speed, or it may change its direction. So the increase or decrease in speed, basically the change in the speed or direction of an object, or both, due to a force is called as change in state of motion of that object. Right? Whether a force is bringing a change in the speed or in the direction, the change is known as change in state of motion. Right? Now give some examples in which force changes the direction of motion. There are many examples. You can say volleyball. You can explain volleyball, cricket, right? Or football is also an example. In all these games, the object, which is a ball, is repeatedly changing its speed and its direction of motion due to the application of a number of forces on it, right? Explain how force can change the shape of an object. Taking two examples, here you have to answer according to the examples. If this is a 3-mark question, you will be giving 3 examples. If this is a 1-mark question, you can give 1 example only. Right? So taking this as a 3-mark question, we will be giving 3 examples. First one being the dough. Right? What do? When you press the dough, its shape changes, right? You basically are applying some force and it is changing its shape. Second can be the spring of a bicycle, right? When you sit on the seat, the spring compresses, changing its shape. Right? It is basically changing its shape. So here also shape is changing because of the application of force. Third can be there are many examples we just discussed in the lecture as well. There is a rubber band example. If there is a simple rubber band kept on a desk, right? But when you expand it, when you apply some force, its shape changes due to the force, right? So these are some examples that force can change the shape of an object, right? What are the effects of force on an object? First one being, it can change the state of motion. Basically, it can bring a stopped body into motion, right? It can bring a body on rest into motion. Secondly, it may change the speed of a moving object, right? It can increase or decrease the speed of a moving object. Thirdly, it may change the direction of a moving object, right? Fourthly, it may change the shape of an object, right? We just saw that the force can change the shape of an object. Fifthly, some or all of the above. Basically, a force can produce 2 to 3 effects as well. It may show 2 to 3 of the 4 above mentioned effects. So these are the effects of force on an object, right? Thank you for your attention, students.